4 of the most commonly prescribed eccentric training methods include tempo eccentric training, flywheel inertial training, accentuated eccentric loading, and plyometric training. To help with implementing these eccentric resistance training methods, practical recommendations were published in the Journal of Functional Morphology and Kinesiology by Timothy Suchomel and colleagues. This presentation, brought to you by Talking Sports Science, will provide a summary of their recommendations. First off, tempo eccentric training is a type of training that attempts to alter the time placed on the eccentric, isometric, and concentric phases of the exercise. Tempo eccentric training increases the total amount of time under tension, which has been identified as a primary driver of hypertrophy. Hypertrophy can be developed through multiple repetition ranges, but is best developed with moderate weight and moderate to large training volumes. Potential limitations of implementing slower eccentric movements are that it may result in lower concentric force, velocity, and power output, and so may not be appropriate during training phases that target these qualities. And it may limit the contribution of the stretch shortening cycle, which may reduce the transfer of training effects to sporting performance. And lastly, tempo eccentric training increases lactate accumulation and perceived effort. Therefore, due to its submaximal nature, the off-season may serve as an optimal time for implementing tempo eccentric training when prescribed as part of a phase potentiation model. This is because during the off-season, moderate loads may be prescribed with a high volume of training to target both work capacity and muscle hypertrophy. This is an example of an off-season microcycle, with the addition of tempo eccentric training on the primary exercises. When using tempo eccentric training, due to the potential for higher acute fatigue and perceived exertion, it's important to monitor the training response. It should be highlighted that although the number of repetitions may decrease with a longer eccentric phase, the time under tension increases. Therefore, based on the desired training goals, it must be decided which is more important, the number of repetitions performed or total time under tension. Moving on to flywheel inertial training. Practical information to optimize flywheel inertial training lacks. However, most studies have used 4 sets of 7 repetitions with 90 to 180 seconds of rest between sets, performed once or twice per week, with 48 hours of recovery between sessions. This set and rep scheme, using isolated single joint movements or small muscle group exercises, has resulted in increases in muscle size. These exercises may be beneficial for bodybuilding and rehabilitation. However, they are not commonly prescribed when training team sport athletes. Using 4 sets of 7 repetitions has been found to improve strength qualities such as muscle force and 1 repetition maximum. When targeting strength, higher inertial loads have been suggested. However, in moderately active individuals, no additional eccentric stimulus was reported with inertial loads beyond 0.0375 kilograms per square meter. For sport performance, multi-joint exercises are recommended, and when executing these exercises, it's recommended to gently resist the inertial force during the first third of the eccentric action, and then apply maximal force at the end range of motion. And if the goal is to receive a larger eccentric overload stimulus, it's recommended that the concentric phase of the movement is performed as quickly as possible. Positive results in power qualities have also been demonstrated using 4 sets of between 7 to 8 repetitions or using 3 sets of between 15 to 20 seconds. To enhance power output, lower inertial resistances are recommended. However, improvements have typically been demonstrated in weaker, less trained individuals. Therefore, it's uncertain if the same benefits can be achieved with stronger, well-trained individuals. Regarding the potentiation effects of flywheel inertial training, using 1 set of 3 to 4 repetitions in a swim start lunge position improves swimming start force variables, and using 3 sets of 6 half squat repetitions improves squat and counter movement jump performance. However, due to the limited inertial load information provided across studies, specific protocol recommendations for stimulating potentiation effects are difficult. So 4 sets of 7 repetitions may be an effective flywheel inertial training protocol for hypertrophy, strength and power. However, because most studies have not involved highly trained athletes, it is unclear if this is optimal for all populations. This is because strong individuals may not receive the same eccentric overload stimulus compared to weaker individuals, likely due to the fact that a stronger person is able to adapt a more compliant strategy that allows them to slow down the eccentric load and control the movement to a greater extent. Therefore, flywheel training may best serve untrained individuals, weak athletes, and those who are going through rehabilitation and return to play protocols. The benefit of using a flywheel device as part of a return to play protocol is that the individual may be able to use their movement velocity to gauge intensity, while the resistance experienced is variable. And it can be used as a motor learning device, as the flywheel may allow an individual to relearn how to effectively transition from an eccentric action to a concentric action. Moving on to accentuated eccentric loading. This refers to a specific programming method whereby the eccentric load is in excess in absolute terms of the concentric load. The exercise selected involves a coupled eccentric and concentric action, and the mode of applying the overload imparts minimal interruption to the natural exercise technique. Prescribed chronically, accentuated eccentric loading can improve strength and power production and provide acute potentiation effects due to its ability to increase eccentric rate of force development. Although a variety of supramaximal overloads promote strength gains, stronger individuals may benefit more from using lighter relative loads, for example, between 105 to 110% of 1 RM during the eccentric phase of an exercise, while weaker individuals may benefit more from using heavier loads, for example, between 120 to 130% of 1 repetition maximum. However, strength development appears to be most effective when the relative difference in the eccentric and the concentric load is greater than 30% of 1 repetition max. Regarding programming, during a phase potentiation model aimed at the overall development of power, enhancing work capacity and muscle size may be programmed initially. The maintenance of the set structure is likely to be most beneficial for work capacity adaptations, while supramaximal accentuated eccentric loading may be the most beneficial for inducing hypertrophy. Therefore, within a straight set, supramaximal loading of the eccentric phase during the first repetition only is recommended, as this is sufficient to provide higher magnitude of eccentric work. For strength power athletes, accentuated loading also has reasonable applications in the late stages of a periodized plan. This is because by training at the highest acute power outputs and movement rates, greater development in power production in the long term can be achieved. Therefore, conservative eccentric overload strategies typically applied to ballistic actions like throws and plyometrics have been explored, with prescriptions being based off the athlete's body mass, ranging from 10 to 30%. In doing so, force production magnitude and rate, takeoff velocity, peak power production, and jump height have all improved. However, further research is needed to help training prescription. Nevertheless, a conservative approach to the total volume and load is recommended when implementing accentuated eccentric loading. This can then be modified based on the individual response over time and in relation to other training performed. Moving on to plyometric training. Plyometric exercises are commonly used to optimize stretch shortening cycle function with intensities ranging from submaximal to supramaximal. Regarding programming, eccentric exercise intensity may be progressed according to the eccentric emphasis and in relation to one's back squat 1 repetition maximum. For athletes who can squat their body weight, plyometric exercises with a low eccentric and moderate concentric emphasis include counter movement jump to box and stair jumps. These exercises involve short ground contact times, a stiff landing strategy, and momentary storage of elastic energy. Plyometric exercises that involve a moderate eccentric and concentric emphasis include pogo jumps and skipping. Plyometric exercises that have a high emphasis on eccentric only include tall to short depth landings and counter movement jump and squat jump landing. These exercises involve longer ground contact time, require a compliant landing strategy, and target force absorption and energy dissipation. Here, the eccentric stimulus may be varied via contact points and the force vector for those exercises not requiring landing only. For athletes who can squat 1.5 times their body weight, exercises that involve a low eccentric and moderate concentric emphasis include rebound jumps and low height hurdle jumps. Exercises that involve a moderate eccentric and concentric emphasis include repeated jumps and low to moderate height depth jump. Plyometric exercises that have a high emphasis on eccentric only include depth landing from a moderate height. Here, the eccentric stimulus may be varied via drop height and contact points, and the force vector for those exercises not requiring landing only. For athletes who can squat twice their body weight, plyometric exercises that involve a low eccentric and moderate concentric emphasis include drop jump and hurdle jumps for a moderate height. Exercises that involve a moderate eccentric and concentric emphasis include depth jump from a moderate to high height and bounding. Exercises that have a high eccentric emphasis only include depth landing from a high to a very high height. Here, the eccentric stimulus may be varied via athlete's mass, drop height, and contact points, and the force vector for those exercises not requiring landing only. Suchomel and colleagues also demonstrate how plyometric exercises may be individually progressed to optimize plyometric performance based on lower body strength. For weaker athletes who back squat less than their body weight, pogo jumps and repeated counter movement jumps are suggested initially, and when athletes become stronger and can back squat between 1 to 1.5 times their body weight, plyometric exercises can be progressed to repeated jumps and hops. Whereas for athletes with a back squat between 1.5 to twice their body weight, bounding and depth jumps using a 30 cm box is recommended. And lastly, Depth/drop jumps using a box greater than 30 centimeters enables the application of an overload stimulus to promote very high muscle tension and force outputs, which is optimized when performed by strong athletes who can back squat twice their body weight. Overall, plyometrics are a versatile method that offer a means to apply an overload stimulus during the eccentric phase using non-specialized equipment, targeting eccentric qualities across the force-velocity spectrum. And that completes the recommendations for implementing tempo eccentric training, flywheel inertial training, accentuated eccentric loading, and plyometric training. However, different methods are recommended in relation to training experience and relative lower body strength. This is because weaker athletes should not be loaded too quickly until they develop technical proficiency. Alongside progressive loading, it's important to program training in a logical manner that will not make the movement too variable. Therefore, from an eccentric perspective, weaker athletes who squat less than their body weight may benefit from performing low to moderate intensity plyometrics, tempo eccentric training, and flywheel inertial training. This will help to develop positional strength as well as learn how to accept/absorb an eccentric load. As more experience is gained and strength continues to develop, individuals who can squat 1.5 times their body weight may require a greater eccentric overload stimulus. Therefore, alongside flywheel training, submaximal accentuated eccentric loading and moderate to high intensity plyometrics can be introduced. And for even stronger individuals who can squat twice their body weight, they may benefit from performing more advanced training methods, such as maximal to supramaximal accentuated eccentric loading and more high-intensity plyometric exercises. The specific training phase is another factor to consider, as it's important to implement eccentric training methods that may most effectively develop the desired fitness characteristics at specific times during the training year. Often, the initial goals of a resistance training program are to improve work capacity and increase muscle cross-sectional area. This type of work is often completed in the off-season due to the high volume of work and fatigue that accumulates. Based on the time under tension, the requirement to overcome an eccentric load, and to overload the eccentric phase, tempo eccentric training, flywheel inertial training, and accentuated eccentric loading are recommended during the off-season, as they may have the greatest potential to improve these characteristics, respectively. Following this phase, typically the focus now shifts to improving strength and early rate of force development characteristics. From an eccentric training perspective, a combination of accentuated eccentric loading to improve strength and moderate to high intensity plyometric training to enhance both eccentric and concentric rate of force development is recommended during the late off-season and early pre-season phases. Whereas during late pre-season and competition phases, because power development is often key, specific eccentric training methods may be performed to provide an optimal training stimulus. For example, during the pre-season phase, accentuated eccentric loading may be programmed using the back squat. However, during the competition phase, power-oriented accentuated eccentric loading and specific high-velocity plyometric exercises may be performed to further develop power. Whereas the transition to off-season involves minimal to no emphasis placed on eccentric training methods. And that concludes the recommendations and considerations for implementing eccentric resistance training. It should be highlighted that eccentric training methods should not replace all other methods of training, but should complement what is already being prescribed. I recommend you check out the full article, the link is in the description. Thanks for listening, folks. See you next time.